Now, in this chapter, we are going to discuss about the bivariate statistics. It's about the two variables having relationship or not. So we are going to have two different types of variables. For example, in your IS, some of you chose relating some variable to another one. So this topic is very important for you, for others also. Now, let's say in your book, for example, there is a given one problem. There is a athletes, and here there are different athletes with their ages, all the age different, and the distance thrown. For example, they are throwing the ball or maybe some discs. I don't know. So here's the relationship between. There is a data given here. So we are going to find, is there any relationship between the age and the distance thrown? So this one for me, some of you, it can be about the time spent on the video games and GPA. Is there a relationship? Of course, there is a relationship between them. You just ask some students and ask their GPAs, and also ask how many hours do they play video games. And then what do we need to do? After I collect data, of course, we need to picture it. So the main picture is with two variables comes with a coordinate system. In a coordinate system, we have two components there. So if I can, always we are going to picture them with a scatter diagram in a coordinate system. So how it's going to be, which one we'll call it in the x component and which one in the y component. In the x component, always go the independent variable, or in some book they call it explanatory. So if you read somewhere, don't be surprised. Explanatory variables, and in a y goes dependent variable. Dependent variable, and in other words, it can be called as a response variable. Now, which one from here, from a givens, which can be independent and which can be dependent? Of course, age is independent, so it will denote them in x-axis, and the distance thrown will be shown in a y-axis. So in this first part, we are going to discuss just the definitions, the concepts. So we'll just put the points. You will have something like this, the points on these are the pair of points when age is 12. Let's say when age is 12, the distance is 20. So you will have just one. So you have here as many points as you have here. They will just mean the points. So when I put the points, when I draw them, then I will try to decide whether there is going to be a relationship or not. So here, how we are going to call, for example, here, as you can see, there is a trend, yes, going up. When the age increases, the distance also increases. So we can say there is a relationship between them. And how we are going to call this relationship? If I have this type of relationship, which let's say with a gradient positive, we will call it positive relationship. When it goes down, the line goes down, we will call it negative. This one is positive correlation, and this one will be negative. And the last one will be no correlation at all. So the first one is a positive, second negative, and the last no correlation. Just the concepts to know. And also linearity. As you can see, there is a increasing as a line, but sometimes it may go not linear one without different type of functions, which we'll see later. And of course, there is a level, whether it's a strong, moderate, or weak. As you can see, if the points are close to the line, we will call them strong. And if they're a little bit far away from the line, some distance, moderate. And if it's too far away from the line, we will call them weak. Of course, they are all these subjective. We'll we will have some calculation. We will see in more details how we can calculate it, how we can see it in more details. And for the negative one also, we have the same. We have strong, moderate, and the weak. And we are going to further in this chapter calculate that strongness or weakness. We will have number for them. Just know it. If there is a tendency like this, we'll call them strong, moderate, and weak. Outliers, as you know from the previous chapter, outliers are what? Like outsiders. When you plot them, you can easily see them. The points which are outside of the trend, and we'll call them outliers. And this one, for example, if it tends the same, goes with the same line, it's not outlier, but this one is outlier. And the last one, S. Let's go back. Here we said, so what kind of relationship here from our definitions which we have studied? We said there is a positive and negative correlation, and there is a strong, weak, and also moderate one. So if I try to draw approximately the line, it will be something like this. So what do you think it will be? For sure, it's what? It's a positive one. There is a positive correlation. And is it strong or weak or moderate? Now, just from our observation, we can, okay, it's a positive. From our observation, we can say that it kind of seems, if I drew the line correctly, it may be strong, kind of strong, or mostly seems as moderate. So as you can see, it's only dependent on our point of view, which is not good. Everyone can see it differently. They may say it's strong or moderate. For this, we need to have some calculation, which we are going to have, which we are going to call strong, moderate. I should have some number. So we can call it positive, moderate correlation between the age and the distance drawn. So what does it mean? If I get older, I can throw more further. Is it so? For example, if I get older, 50 or 60, is it going to distance be the same? So what I have only within this information, but we also are going to learn, can we predict what's going to be after my age increases? Is it still possible? Is it going to be in the same way? Is it going to be a line or not? So this was something for you to think and also to reflect on your explorations, IAs. And last part, definition, causality. Causality, whether it happened, whether there is a relationship with a coincidence or not, causality. For example, in your book, two good examples, the arm length and the running speed. Of course, when they check it, arm length and running speed, they may show you positive, strong relationship. But it doesn't mean that your arm length makes you run faster. But it actually dependent. They are both dependent on different variable, which is age. So that's why, because of the age, these two have strong correlation between them. So when you do your researches, you also should consider, is it by causality or is it by coincidence? How these got correlated between each other. Or also there is an example, for example, the number of television sets sold in London and the number of stray dogs collected in Boston. They show the strong positive correlation. For example, it may happen, you may have these data and may show you strong positive correlation, but what does it mean? It's a coincidence. There is no relationship between them. We can see that and say that. So when you are going to work on your research, you should pay attention also to these kind of cases.